Welcome back to yet another homework solution video, this time for Chapter 5, Lesson 5, Day 2, Real-World Problems with Average Speed. So again, with these problems, doing a quick little sketch is a real great way to organize the information. And often with these problems, there's a couple steps that you need to follow before you can do your final calculation to get your answer. So let's see what we've got going on here. Mr. Evans and Mr. Lopez stay at the same place. Mr. Evans drives 72 kilometers from work. I'm going to highlight his stuff with purple, I suppose. At a speed of 48 kilometers per hour. So already I'm thinking that we have the distance and we have speed for Mr. Lopez. I'm sorry, for Mr. Evans. Mr. Lopez drives 130 kilometers from work at a speed of 65 kilometers per hour. So we have Mr. Lopez's distance and speed. They both leave their workplaces at the same time. Who arrives first? So this sounds to me like a question of time. So I'm going to organize this information to see what I have and what I can figure out with it. So if we know here's not a very straight line, close enough there. Mr. Evans only drives 72 kilometers. Mr. Lopez drives 130. So I'm going to put, if here's the home, here's Mr. Evans' work, and here is Mr. Lopez's work. I know that this distance is 72 kilometers. I'm going to put that in purple because that's his color. 72 kilometers is that distance at a speed of 48 kilometers per hour. And then Mr. Lopez, he drives a distance of 130 kilometers at a speed of 65 kilometers per hour. So here, when we're looking at this, we can see that Mr. Evans, he might have a shorter commute, but he's driving at a slower speed. He's only driving 72 kilometers when Mr. Lopez is driving 130 at a faster speed. So we just have to see how much is that speed and that distance going to affect the time of their commute. So since we're looking for time and we want to know who arrives home first, we're going to want the smallest amount of time. So I'm going to get that blue. So we know from class and from all of our discussions that if we make our little pyramid here, our triangle of average speed, I guess, we know we have distance, speed, and time. And this can be really helpful because it can give us a visual reminder of speed here is distance over time. And you can kind of see that because it's like distance over time, like that blue highlighted line there is like the line in a fraction. Then we could also see that time equals distance in red over speed. We could do that same type of idea here. Time equals distance over speed. And distance equals speed times time because they're right next to each other that way. And so from that one picture, you can see which of you can come up with all of the formulas and help you decide that in this case, since we're looking for time right here, that's going to be the formula that we need. So I'm going to give you a moment to pause and I want you to see, can you calculate the time of Mr. Evans's commute and then the time for Mr. Lopez's commute using this equation, that formula. So pause the video here, do a little bit of calculations, and once you're done, you can hit play again and we will check and see how you did. All right, hopefully you have done some work here, and so we can see Mr. Evans, if we're trying to calculate his time, will equal distance, 72 kilometers, divided by 48 kilometers per hour. And I'm going to think of this like it's a division problem, 72 divided by 48. Or I could have simplified this fraction, but I know this 72 is a 48 and a 24. And this now looks really familiar, that this is 1, and then 24, I notice, is half of 48. So it looks like Mr. Evans's commute is 1.5 hours, 1.5 hours. That is quite the commute every single day. Now, Mr. Lopez, we know time equals distance divided by speed, or distance over speed. So his time is 130 divided by 65. And I know a 130 is a 65 and a 65. So his time is 2 hours. These guys, they spend a lot of time commuting. So who arrives home first? We know that it is Mr. Evans arrives home first. Because his commute only takes 1.5 hours, and Mr. Lopez's takes 2 hours. So for question B, what is the difference in time for them to reach home? Well, 2 minus 1.5 is 0.5 hours or 30 minutes. It doesn't specify, but either one is the same amount of time. So that problem is relatively straightforward once you identify what information you have, and then use this handy triangle to remember your formulas. Moving on to Ms. Chavez, and I'll try to do the same thing here, where we get this set up with the model, and then I'll give you an opportunity to pause the video, and then you can do some work, and then check back to see how you did. So Ms. Chavez had a dinner appointment at her friend's house at 5:30 p.m. She left her house at 11 a.m. and traveled in her car at an average speed of 55 miles per hour to her friend's house that was 330 miles away. Now, I probably don't even have any friends that would be willing to drive 330 miles just to have dinner. That's some good friends. So we need to figure out what time did Miss Chavez reach her friend's house, and was she late for the dinner appointment? So we know that in here, this distance from one to the other is 330 miles is our distance, and we know the speed is 55 miles per hour. And so we have to decide the time, or we have to calculate that time. Going back to our triangle, distance, speed, time. That means time equals distance divided by speed, because we have distance over speed. Okay, so let's see how long it took Miss Chavez to get to this dinner. That's amazing. Okay, so this time equals 330 divided by 55. Now, if I were to set this up and do long division, I know 55 goes into 3 0 times, 33 0 times, and I'm just going to then have to count by 55s to see how many times it goes into 330. That is not super helpful, but I am instead going to do some branching, because that's going to be my best bet from here. So I know 55 plus 55 is 110. And so, in here, there's actually going to be 3 110s. That one's not that bad, actually. So 110 divided by 55 is 2. So that means the time is 6 hours. So Miss Chavez is driving for 6 hours to get to her friend's house. So if she leaves at 11 a.m., I know 1 hour would get her to 12 o'clock. And then if she has 6 hours, that means 5 more hours will get her to her friend's house at 5 o'clock p.m. So she will be there in time. So she arrived, Miss Chavez arrived at 5 p.m. She was not late. Awesome. Good job, Miss Chavez. I forgot to tell you when to pause. Man, that's a bummer. Okay, well, maybe for this one. So Nicholas took 15 minutes to run from point G to point H at an average speed of 120 meters per minute. He then ran from point H to point G in 20 minutes. Find the average speed of Nicholas when he ran from point H to point G. So here we're going from H to G, and we know our time and we know our speed, 15 minutes. At a speed of 120 meters per minute. Then, that is on the way there. On the way back, the time was 20 minutes. We don't know the speed, and in order for us to calculate the speed, we know from our triangle For us to calculate speed, that's going to be distance divided by time. We need to know distance, and we don't have that piece here, and we don't have that piece here. But whatever our distance is from H to G is going to be the same as our distance from G to H. So pause the video and see, can you calculate the distance from H to G? Yeah, pause and do that first. All right, hopefully you've had a chance now to calculate that distance. So if we know that to calculate distance equals speed times time, because distance equals speed times time, our first piece of work here is going to be our speed of 120 meters per minute times 15 minutes. Now I'm going to use a doubling and halving strategy because I'm not going to. 120 times 10 and 120 times 5. 120 times 10 is 1,200. And then 120 times 5 is going to be half of this because 5 groups is half of 10 groups. So I know that's going to be 600. So our distance is 1,800 meters. So if that's the distance from H to G, then that will also be our distance from G to H. So now that we've calculated that distance, you have the missing piece of information to be able to calculate that speed. So take a moment, pause the video, and calculate what is Nicholas's speed from G to H using this information here. All right, let's check your calculations. Speed equals distance, which is 1,800, divided by time, which is 20. So I'm going to use a proportional relationship, divide both of these by 10, and so I have 180 divided by 2, and that's going to be 90. So Nicholas's speed from point, oh, there's a typo. Wait, I had these flip-flopped the whole time. That's supposed to be a G. That's supposed to be an H. Oops, sorry about that. So Nicholas's speed returning is 90 meters per minute. Awesome. So hopefully that is the work that you got. If you have any questions, rewatch the video, pause it, or you can check out your workbook for Chapter 5, Lesson 5.